Hello students, and welcome to another video. I'm teacher Mr. Flynn, and today we're going to be reviewing and giving instructions on how to do the level 1 proof for intermolecular forces. Basically, the first 2 points are directly from your notes. Like, I can explain the difference between dispersion forces, dipole interactions, and hydrogen bonding using models. Well, those models, I kind of drew them out with you, okay? If you need to, use that as your guide, but I'd like you to find your own examples. Don't just give me the copies right from the notes. But they will look similar, but instead of using neon as the example for a dispersion force, go find another example, okay? Ask Sylvie or ask one of the AI tools to help you come up with some examples to help you build these models, but they will look very similar to mine, all right? The second one is I can describe how intermolecular forces affect the states of matter and how it relates to the kinetic energy of particles. Now, what you could do is use this same point. I can describe point 2, and looking at point 1, you have your drawings out. You can actually talk about why the example you chose is a solid because of the interactive forces between them. Okay, so you might want to think about doing part 1 and part 2, these 2 bullet points together, and then just relating the states of matter for them, okay? Like, for example, water is a liquid because hydrogen bonding is pretty strong, while neon is a gas because the dispersion forces are pretty weak, and because they don't want to attract it to each other, they stay away from each other and they form and they stay into a gas state. While water is forming a liquid at room temperature because hydrogen bonding wants to keep those water molecules close together. Okay, and it takes a lot of energy to actually take them and turn them into a gas. Okay, all right. So you may want to think about putting those 2 together. But remember, this is your example you're coming up with, and I've given you tools to help solve these. And then the last one is I can explain the difference between molecular, ionic, metallic, and covalent solids and distinguish their individual properties. There is a great resource on page 120 and 121 in the textbook, okay? Go look at those pages. It will literally outline for you their properties, and it will actually give you examples of each, okay? And I'd like you to map it out for me and show me the differences between molecular, ionic, metallic, and covalent solids. So come up with an example for each, and then tell me their properties and what makes a ionic solid different than a covalent solid. Okay, so go and look at those pages on 120, 121 and go map that out for me. Okay, thanks again for watching. If you have any questions, please come talk with me.